Moving on to the fifth strategy for our strategies to solve limits, one-sided limits. Now, this strategy you'll have to use when you run into limits that have an absolute value in them. And out of the 5 strategies, I'd say this is probably the second most challenging one. Number 4 was the most challenging one, but this one could get a little tricky as well. So, first off, we have this limit. First thing you always want to check, can you directly substitute 6 in? Well, if we substitute 6 into the numerator, we get 0, and if we substitute 6 into the denominator, we also get 0. So we'll have an indeterminate form of 0 over 0, so that won't work. So the trick is that you want to change this function here, this absolute value of x minus 6 over x minus 6, into a piecewise function. So let's just work with this absolute value for now. So what's an absolute value again? Basically, if the absolute value, it changes any negative number inside to a positive, and then any positive stays as itself, right? So we can make this into a piecewise function. X minus 6 will just stay itself only when x minus 6 is greater than 0. Right? Or when x is greater than 6, then we can just keep it as x minus 6. Now, if x minus 6, if the portion inside the absolute value is negative, we're going to have to multiply whatever that portion is by a -1 to change it to a positive. And that's only when x minus 6 is less than 0, or when x is less than 6. Okay, so we got this piecewise function. We change this to a piecewise function. The absolute value of x minus 6 is equal to x minus 6, so like positive x minus 6, only when x is greater than 6, and it's negative x minus 6 when x is less than 6. So now, let's change this whole function into a piecewise function. So let's separate these. So let's rewrite this function here as f of x is equal to the absolute value of x minus 6 over x minus 6. And if we write this into a piecewise function, the absolute value, x minus 6, is equal to positive x minus 6 over the denominator, x minus 6, when x is greater than 6. Alright, and then the absolute value of x minus 6 is equal to negative x minus 6, and then we rewrite the denominator here as x minus 6, and that's when x is less than 6. Alright, so we're pretty much doing the same thing as we did here, except now we're just going to have a denominator of x minus 6. So, we can simplify this. So, the numerator and the denominator cancel out, so we'll just be left with plus 1 when x is greater than 6. And we'll be left with... here, these can cancel out as well, these two x minus 6's, and we'll just be left with -1 when x is less than 6. So we took this function and we transformed it to a piecewise function, then we simplified it. So now we have this piecewise function, which is equivalent to this, right? And then notice how at 6 it's not defined, because if we plug in 6 into the function, we'll have a denominator of 0. So it's only defined for when x is greater than 6 and when x is less than 6. Taking this simplified function, we can write the limit. We could rewrite this limit. The limit as x goes to 6 of f of x, where f of x is equal to this piecewise function. So it's equal to 1, or positive 1, when x is greater than 6, and it's equal to negative 1 when x is less than 6. So what we can do here is we could just graph it. So obviously 6 is going to be our x point where the function is going to be different. So any x value is greater than 6, the y value is just 1. And then, so we'll put a 1 here, and then notice how this has to be a whole at 6 because it's not defined at 6. It's only for values greater than 6. And that's just a straight horizontal line at 1. And then for values less than 6, the y value is negative 1. So we'll put a hole here, and it's just a line at negative 1. So looking at this graph, we can take the one-sided limit. So we'll take the limit as x approaches 6 from the negative side of f of x, right? F of x is this function, or this function here. This is also f of x. So as x is approaching 6 from the negative side, the y value is approaching negative 1. And then the limit as x approaches 6 from the positive side of f of x, well, if we're approaching 6 from the positive side, the y value is equal to positive 1. And then remember our definition of a limit. If it exists, it has to approach the same value from both sides. But since it's approaching negative 1 from the negative side and positive 1 from the positive side, we can conclude that the limit as x approaches 6, the general limit, does not exist.